Hey guys, today we'll be talking about the unit circle.
So as you all know, the upcoming test requires us to memorize unit circle values. This may seem tough, but there's a simple trick to remembering these, slices of pie, so to speak.
Let's begin by looking at the first quadrant. The trick we're going to teach works for all quadrants, but not having to deal with negative signs will be helpful in understanding it.
The standard unit circle has a typical pattern: 0, pi over 6, pi over 4, pi over 3, and pi over 2.
Each of these values has a cosine sine value associated with them. For example, y'all should be pretty clear that the cosine of 0 pi is 1 and the sine is 0.
The cosine sine values of the division of pi are a bit more complicated, but they share a common theme as well. We'll go over these patterns from the most simplistic to the most complicated.
A word of caution. As the slide says, these rules do not indicate which quadrant an expression is located in, which may influence the values positively or negatively. In other words, these patterns do not tell whether the value has a negative sign attached to it.
Here we go. If an expression can be simplified to a pi or a 0, or a pi is in the denominator, the cosine sine values are 1, 0. Example, sine, 4 pi over pi equals 0. The cool thing about this one is that you can tell whether the cosine is positive or negative. An even numerator coefficient indicates a positive cosine value, while an odd numerator coefficient indicates a negative cosine value.
Next, if an expression can be simplified to contain a denominator of 2, the cosine sine values are 0, 1. Example, cosine 9 pi over 2 equals 0. You technically can tell whether the sign is positive or negative, but it's a convoluted pattern. Starting from pi over 2, every other odd coefficient has a positive sign. As I said, it's convoluted.
The rest are relatively straightforward, but don't have any tricks about the quadrant it's located in. The examples assume you've already figured that out. If an expression can be simplified to contain a 4 in the denominator, the cosine sine values are square root of 2 over 2 and square root of 2 over 2. Example, cosine 6 pi over 8 equals negative square root of 2 over 2. The radian expression in the above case can be simplified down to 3 pi over 4, satisfying the rule.
If an expression can be simplified to contain a 3 in the denominator, the cosine sine values are 1/2 pi and the square root of 3 over 2. Example, cosine 14 pi over 6 equals 1/2. Again, the radian expression can be simplified, this time to 7 pi over 3. This takes some more trickery, as 7 pi over 3 is past a full circle rotation and thus is equivalent to the position of pi over 3. Keep a lookout for these types of problems.
Finally, if an expression can be simplified down to contain a 6 in the denominator, the cosine sine values are square root of 3 over 2 and 1/2. Example, sine 7 pi over 6 equals negative 1/2.
We'll pause for about 15 seconds so you can finish looking over these rules.
Now that you have some tools in your toolbox, here's a sampling of practice problems. Good luck! Make sure to pause the video as we'll be showing the answers shortly.
And here are the answers. Hope you got them all right.
Well, that's all for today, folks. You learned some new unit circle tricks and are poised for success for the test.
Thank you for watching.